Hello viewers, welcome to my channel Science to Technology. In today's show, Rocket Monday, we're going to talk about Starship Flight 11 test. So let's dive deep into it. So this was IFT Integrated Flight Test 11, and yeah, this is the 11th try of test, which is world record. Last time I checked, the longest rocket is like four try, and they're like, okay, deploying payload into orbit, and I do not mean dummy payload, like actual payload. So yeah, this is unique, and this was done on 13 October 2025 and 23 hour 23-minute universal time coordinate. So that was funny time, and this time this is the last block of V2 designs. As in, if you look into Falcon 9, it has went through multiple revisions, and there were categories of major revisions, which was block 1, block 2, block 5. So they are at block 2, end of block 2. This is the end. So this is ship 38. Now here's the, why the heck 11th try is like 38? Well, SpaceX has this idea that instead of finishing the rocket, let's build a factory first so we can mass produce the rocket. That somehow does not go to orbit, but let's build a factory to build the rocket before we have a finalized rocket design. But that's why, and they're building it, and they're like, oh, we can change that. Okay, throw that away, change it. Okay, well, let's do crush testing, let's do this and that. So that's why the numbers are so high. And this time they had 8 Starlink mass simulator. And if you're like, okay, why the heck only 8? Aren't they supposed to have like lots of them? Well, V2 engine is not that powerful. So that's how much they're gonna get. And no booster recovery was done, simply because booster was also going through major revision. So all of this thing was the last attempt of V2, basically to gain data, to learn things about dynamics, and the end. Basically they sold this, now they have to deliver that. And let's just see. So what was the event? Well, event was very, what we call nominal, meaning if you look into a SpaceX website and they're like, okay, this is this thing what we want to do, they managed to achieve all of it. So that's done. Now they had minor fire issue and tiles falling, which again, fire issue is a bit unique, but tiles falling is like duh every time. And dummy payload was deployed, which I have to say, this was time it was much better. I looked, compare this to last one, they actually had one strike event also, meaning kaput happened. So this time it is much better. They have improved, and again they're eating it. It's like whoo. So I think they learned a lot from the last test, so that is good. They also tested the V configuration of the booster, because you have to understand booster comparatively, it's not putting enough delta V into Starship second stage. Basically, from booster's point of view, take all rocket boosters, it's not dumping enough energy into second stage. Why? Because it has to keep so much fuel for landing. So they're like, okay, how do we reduce that penalty? So they are like, okay, what if we do aero braking rather than engine braking? Okay, that has some pros and cons. You balance it out. What if like we can yeet the engine? You're just like yeesh, go YOLO on the engine power. So the burn time, basically the propellant consumption would be low, but G-force would be higher. So they're like, okay, that's how they are balancing. So V is another of those knobs that they are turning and twisting to like achieve the ideal scenario, where they're like the penalty on like basically stage 2 is minimal. It's like whether I was reusing it or not reusing it, the penalty should be negligible. That's why they even removed the landing legs. The idea is to remove the penalty. Now, physics does not allow you to remove it, but reduction, go YOLO. You can keep reducing it. So that is why. That's why the booster comes and lands. It's like they actually managed to hover, and after that they cut the engine and boom. So that happened. And this would be the last time of this water shower thing, which was stupid. Everybody called it stupid. Everybody, like, people who were smoking alone, they're like, no, this is awesome. No, it was stupid. Best case scenario, I can say, is simply because they did not have license or permit to dig. It has happened with NASA also, where they're like, okay, we want to dig a trench, and like, you know, other agencies and government is like, no. So NASA is like, let's burn the money, let's build a pit. They literally have to build a, you know, raised structure. So that's why many times you see rockets going like this. Yeah, there's a structure, man-made structure, so they can put the flame trench. So this time, this is the last time of 90-degree rocket fire. After this, everything would be 45 degrees. So second tower already has flame trench put into it. The third tower they are building in Florida, that also has a curve system. Since this was at best case scenario was a rush order, at worst case scenario, Elon Musk actually thought that it could work long term. Short term, I can easily say anything can work in short term, like 1 or 2 firing duration. But you're like, okay, I want long term rapid reliability. Yeah, good luck with that. You should see, like, there are a lot of people who did analysis of like how many attempts it took to like, oh, we are still working on the shower head itself after every launch. Because again, the design 90 degree is not a good design. That's why 45 degree. Like we learned this in World War II. Tank armor has to be sloped. The shall have slopes. So these are the event. And again, I have to say, the yeeting of the satellites were dummy satellites. They were genuinely smooth. So what was the outcome? Well, let us be very clear. This system was almost close to actually working if they would have stayed to logical scenario of, hey, we have tiles, let's glue it, how every single system does. They're like, no, what if we have rapid reusability by not gluing it and designing a complex system of hinges and weldings and all that, which again not only adds mass but also adds failure point, and that has been failing. All this whole point that is failing. And let there be clear, TPS is sorted, as in like thermal protection tiles at this point in time is done. It's a sorted technology from 1970s. That's why you never have to worry about like, okay, there is a small mini shuttle, so to say, that goes into orbit, stays there for almost 900 days. He has multiple years, comes back, never has a tile failure. Heck, space shuttle never had a tile failure. The only time, unfortunately, it had a failure, it was a boom event, meaning space shuttle was going up, insulation frame were kabam. So I can't blame heat tile failing in those sort of scenario. You are talking about Mach speed crash with almost 2 kilogram of insulation foam. Good luck with that. Like almost bulletproof glass will shatter at that point in time. So that's not a tile's fault. You never have a scenario where tile fails. Never happens in Dragon, never happens in Apollo, never happens in Space Shuttle. It does not happen. We know how to do it. It's just like, he's like, okay, we want to use hexagon. That was a genuine issue with Space Shuttle. But it was not an issue of stupidity. It was an issue of complex geometry. They had a complex geometry. It was a cylinder that had a wing and aerodynamic wing. It's not just a flat. It's an aerodynamic curve that necessitated those sort of unique geometry. You got a cylinder, bruh. It's a cylinder. And when you have complex geometry like the nozzle, you have glued tile. They have never failed. They have never failed. He's always like, he's all concerned like we should use stainless steel because if heat tile fails, it's like heat tile never fails. That does not happen. Like that is done, that is sorted. The first heat tile actually did fail when NASA was testing it. And again, in atmosphere, not with people inside, not with actual rocket. Just like pulled it up, fell down, and then all the tiles fell. They worked their ass off to make a new adhesive that compensate for all issues. It worked. And again, right now it's a sorted technology. There, flaps, hinges and all that done, sorted. Is this hexagon things that are failing? Why? Because the bond between the TPS and the body is the weak link. This idea of like having 3 hook points, that is the weak link. So, and again, this whole idea rapid reusability is like, what if you just glue it and have a scanner built for it so you can rapidly scan it, which tiles had to be replaced. And again, it's a cylinder. It's a dumb thing to do, like, okay, it's a cylinder, oh, I have done some advanced hexagon. No, it's a cylinder, it's super easy to put hexagon, like super easy. Cylinder, you do not have complex geometry, and where you do have complex geometry, you have unique tiles. So that is the main weak link. This is the reason why this is 11th try and still not like it just works. Now, tile is not the fault, the structure is not at the fault, aerodynamics is not at the fault, the avionics is not at the fault. It's just this desire of having tiles that you can crack and put new tiles there. It's like you can do that with glued tile also. So that's the whole issue. That's why it is at 11 try. That's why if you watch Elon Musk's original interviews when Starship was first, like 3 or 4 launches, we're gonna be ready. And that's the time he was claiming 2024 moon landing. I was like, bro, 2024 orbit would be awesome. Which again, they haven't reached orbit yet. So outcome was to be expected. Like they have like so many tiles gap, whereas like, okay, what if we try this thing? How much stainless steel can handle? And other than also that, tiles failed. It's like, it's normal now. So what is their hope? Well, their hope is V3. We know V2 does not work. We know V2 does not work. How about V3? V3, the first time the pad will become normal rather than having which could have a positive impact. We never know. It could have a positive impact because sound pressure, instead of bouncing and hoping that water absorbs it, it will be redirected. So that could ease the situation. So let's just hope for that. Normal trench may give that. And again, there are some smooth curves in Tower 2 frame trench. You can see that it's available now. And hot staging ring will be integrated. And again, this is almost old school Soviet Union era rocket system, and they have dome, smooth dome. All the plumbing is inside. They have smooth dome, and on top of the domes they have reinforcement. Basically, they have second steel and third steel. The idea is because again, you're gonna do hot firing, and this is supposed to be reusable. They have enough reinforcement that this puppy should be able to tank it, so to say. A tank should tank it. That's the whole point. And but again, that does add weight. To reduce weight, they are eating one of the basically grid fins. So instead of having 4 grid fins, they are only gonna have 3 grid fins. And you're like, okay, did anything else change? Yes, they made it bigger. I'm like, what's the point then? Well, you are also removing hydraulics, electrics, all of those auxiliary things that you need in order for that hinge to work. That does reduce weight, even though item itself can get bigger. And there's another thing, they are shrinking 2 items. First, catch points are no longer independent, they are integrated with that. So overall, I think that's how they got the mass wiggle room in order to have 3 systems, reduce the physical reinforcement. So you have reinforcement for the hinge and reinforcement for the catch pins. No, combine both of them. That's how they are reducing weight, and tada, integrated hat. And all hopes at this point in time, the whole reason Starship is actually still not useful, because again, if you look into what Elon Musk himself is saying in his Twitter, it's barely like 10 tons to orbit, 20 tons to orbit. It's basically useless at this point in time. You can just put some money in Falcon Heavy second stage. Like, why? The second stage is copy paste from that. So it has delta V, it does not have the oomph where you can load it heavily. So have a reinforced structure with a bigger fairing, that would be better at this point in time. So why is that? Well, the original design was Raptor engine with carbon fiber. Carbon fiber would have been super light, and larger dimension would have allowed it to be far better at surface area to volume ratio. But that was, I think, 12 meters. So they were going bonkers. But again, they scaled it down. They scaled it not too much. They went to stainless steel. Stainless steel is too heavy for this. That's why Falcon 9 is made out of lithium aluminum alloy. And the engines were not up to the mark. So they are hoping that engine number 3 will be up to the mark. Will it be? I would place the bet to be low, simply because engine is not that powerful. Like, compared to Mark 1 to Mark 2 engine was like, whoa. Mark 2 to Mark 3 engine is like, meh. But the core difference is auxiliary requirement of this engine is gone. Basically, the cowling that you need for thermal protection and all the extra plumbing. Basically, this engine is far more agile, so to say. Basically, it's efficient in terms of mass. It's not more oomph. It's just like, I'm light. So let's just say this is 1 megawatt power. It's just like, I'm 1 megawatt, 10% the mass. So that could allow them to have this stainless steel behemoth and actually deliver that 100-ton to low Earth orbit. I'm doubtful, but let's just see how good this engine is. Be mindful, they cannot ever share the full detail of engine, simply because it's ITAR regulations. So that's why everybody thought, oh, stainless steel is so awesome. It's like, no, it's not that awesome. That's why we don't use it. And then we started to use it, and they're like, yeah, your engine is not up to the mark. It keeps going boom. Even in this time, there is one engine failure in the booster. Again, it restarted, but again, engines have been pushed way too hard. So all hopes are in V3 updates so that it can actually start to do work. So what can we expect in the future? Well, reality is they have to deploy payload in orbit. Nothing else. Oh, we have a factory, it does not matter. Oh, we have rapid reusability, it does not matter. Do you deploy payload in orbit? Yes or no? Because the third launch of this puppy will have humans on site. Second launch of basically Blue Origin will have payload. And be mindful, the first one also had payload that it deployed. That's thinking. First launch, payload deployed into orbit, and again, landing failed, but again, you are not even trying to land here. You are just going kaboom. So what's the point? So you have to deploy payload to orbit. That's the first job of a rocket. I have not found any system where rocket failed as many times. Like Falcon 1, 4 times, go home. Saturn 5, 5 times, go moon. So this whole idea of like 13 launches, 14 launches is like, starting to take one. And why there is a penalty for that? Well, Artemis money and time is not infinite. Meaning, if this does the third mission and Blue Origin slowly starts to catch up, they're like, bro, like, ramp it up. Or it's like, okay, we can make 38 models. Like, what's the point? You still have not deployed even Starlinks into orbit. And you're supposed to deploy 60, 70. You only have sent 8 or 9 mass simulators. That's really like, basically stainless steel is too heavy for this architecture. Or engine is not up to the mark, depending how you want to count it. And private equity, they do have a lot of private equity, but that has upper limits. It's not infinite, especially if you're burning money faster than you are earning it. That's why they need to deploy Starlink's heavy satellites as quickly as possible. Failure to do so will have severe consequences, like severe. So now, can this problem be solved? Of course it can be solved. That's what we humans do. We have a problem, we solve it, the end. So that can be solved. Question is, can they do it in the allotted time? That's the main thing. So what are their options, like scientifically? Well, the best option they have is going from stainless steel to lithium aluminum and throw away this idea of like, what if we hinge the tiles? It's like, what if you glue it? You have glued tiles. And if you just built a scanner, bro, here's deal. use a super continuum laser that gives you a very wide spectrum and simple basically scanner array where you have a prism and a normal system, basically scanner or sensor, so to say, and behind that have a what we call grating, diffraction grating. Based on that, scan the whole thing. You will get a like almost like how your camera flat bed scanner works, have something like that. It would be hyperspectral. You can know every senior basically minute crack on the tiles, and it could be done robotically. Just go and then like, okay, go there, yeet this tile, done, go home. It can be automated. It was in 1970s. The design philosophy of space shuttle was old. They did not have robotics. They did not have super continuum laser. They did not have super cheap, basically, digital sensors. We have them now. You can automate it. So it is solvable. Stainless steel to lithium. So at that point in time, the mass penalty would be removed. At that point, I think they can actually do 100 ton to low Earth orbit or 150 ton. Or let's just say they are not doing that. What is other option? Other option is making second stage temporarily single use, meaning just like get this puppy starting to print money, get Starlink satellites into orbit, then we'll fine tune and figure things out. That can be done. And gluing thermal protection tiles, like you have tiles on a complex geometry, it's like I got this, and I'm like, okay, what if we have 3 points attaching? It's like just use the same glue that you are using there. Oh, and this the time during return, there was some tile that popped off and it started to catch fire on the nose. It was catching fire on the nose. So, and again, I'm genuinely shocked how the heck people bought this idea. It's like, we're going to refuel second stage. It's like, bro, physics is known. Thou shall not have second stage. Thou shall have third stage. Have a third stage. Have a smaller third stage. Heck, have 2 launches. One deploys the payload, another deploys the kick stage or big ass stage in this scenario. Dock them, go to the moon. Saturn V. Cost effective, efficient. You do not need 21 refueling. Like how the heck people are like, oh, 21 refueling. Like, do you know the cost of that much liquid oxygen? It is huge. That much liquid methane, it's huge. That it's almost reaching a point that those giant container ship, it's gonna consume few of them just to refuel one tiny on top. So that's just dumb. Like I'm reasonably sure they're going to cancel it. Exactly how they're going to cancel this one, and exactly the same reason why NASA's budget has to be cut. And again, it is being cut, and people are like, oh, now why NASA's budget? But yeah, because they charged Congress for like $500 million a telescope, James Webb telescope. Yes, it was 500 million. Then they're like, okay, upgrade it to 1 billion. Cool. 10 billion. You have to cut their budget. They cannot manage money. Same happened here also. This puppy is supposed to be 500 million or less. It's $2 billion. They have to cut it. So this can also become the same thing. It's like, oh, we are giving you money and outcome is not there. And once that, you're like, okay, but it's mostly private money, mostly his own money. Yeah, once you remove the contract, things become less appealing very quickly. Private equity starts to dry up very quickly. So this was my presentation on basically what the hell happened on the 11th try of a rocket that's supposed to be on moon by 2024. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike. Press it twice to show me excitement. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free. And as always, thanks for watching.